All right, so let's get started. So today's lecture is what hackers can teach academics, open source research in photovoltaics. And this is a way, it's a methodology of doing research that's a little bit radical, it's a little bit abnormal, and it's not like anything that you've seen from probably any other professors that you worked for in the past. The reason that I use it is it's extremely effective for actually getting things to change in the real world, because you're actively sharing aggressively in order to encourage more people to sort of join your efforts and the type of research that you're doing. So we're going to start off with some basics. We'll talk about what hackers are, what free and open source software is and free and open source hardware, and how this sort of hacker ethic has begun to develop technologies that can benefit everyone. In specific, we'll talk about open source appropriate technology, which is what the Appropedia website is for, and the second lecture in this series we'll cover. We'll talk about how to use this open source wiki environment to do research through your literature reviews, which will be the first assignment in this class, the methods and the protocols, and then finally the results and outreach. We'll talk about the advantages of using this methodology and the disadvantages, and then kind of get started for how you can actually use it yourself. So as a background, a hacker in the news is generally a bad thing. A hacker is someone that they think of as breaking into a computer system to do something malicious. But that's not the real definition of a hacker. A hacker is just a computer programmer who shares a kind of an anti-authoritarian approach to the way he or she does their coding, and they develop free and open source software. And in the beginning, more or less all the computer coders, everybody that wrote code was a hacker. They actively shared the source code, and this was happening in labs like MIT's, where one person would write code and solve a small problem, and they'd share it with the others. They would build off of it, and that's really how we got the beginning of computer software and the internet. And if it had been sort of followed the current methodology, we wouldn't have the internet today, because things like the carriage return would be patented, and then you'd have to get a license in order to be able to use it. So even sort of closed source software advocates such as Bill Gates acknowledge that we are very fortunate to not have a closed system of IP for software when it started. And so you have these hackers that are creating free and open source software and actively sharing them. And this is, for those of you that are into coding, you know that this is quite common. Most software programmers kind of cut their teeth on open source software. And it underlines basically the entire backbone of the internet. Your Facebooks, Google, Amazon, all of them are running on open source software. The servers at this campus, we're all using open source software in the background, even if you don't happen to have, say, Ubuntu or some version of Linux running on your own personal computer. So the way free and open source software works is you share the source code, the actual program itself, in a way that other people can utilize it. Now, they might just want to read it to understand what's going on in your program. They might want to edit it or copy it or make it better. And when you share it, the license that you're tagging onto it is a viral license that says you're allowed all these freedoms, but if you do anything to my code, you have to reshare it back with me, back with the community. And so that's how software that's open source starts off small and then gets bigger and bigger and better and better and better as more and more people sort of glom onto the project and kind of create it to what it is now. And so there's sort of this kind of dichotomy in the open source software world. And you have basically kind of the open source part that says you just have to share your code. And then there's the free part that says freedom is really important. It matters. It matters that people are allowed to make improvements, are allowed to do something better to your software, to move it forward. And the model that we're going to follow on the hardware side of things is both combined. So it's not just letting people see your code, which is nice, but letting them basically do anything with it. And so there's all different kinds of examples of open source software. The ones you've probably used on a daily basis is Wikipedia. That is pure open sourceness. The software that writes Wikipedia was open source, and the content was generated by open source methodologies. Have any of you edited Wikipedia? No. One time. So that's excellent. So some people many people from around the world, millions of people, have contributed to that encyclopedia. And if you compare that encyclopedia to, say, the Encyclopedia Britannica, it has more coverage, much, much more coverage, orders of magnitude more coverage, covered in more depth, with links to videos, with links to images. It is, from a kind of objective viewpoint, clearly significantly better than what has sort of what was done by Britannica, which had PhDs and Nobel Prize winners writing their actual entries, versus you have the crowd of everybody on the planet that has access to a computer essentially, and an internet connection can contribute to Wikipedia. And so you got a better result. And that's sort of what we've seen through all of the software. So the reason Linux is kind of the backbone of the internet is because it's better. It's a superior technological package because you've had hundreds and thousands of people contributing to it and making it better. Now, just because something's open source, or even free and open source, doesn't mean that you can't make money off of it. Red Hat is a $1 billion a year company. All of their products are free. So right now, if you want to get the Red Hat version of Linux, you can download it. You can put it on your computer. It's 100% free and totally legal. You could burn DVDs and go outside and try to sell them on the street corners. That's completely legal. The way Red Hat makes their money is by offering services on top of what they're giving away for free. So they've built on an open source platform. They are continuously making it better, and then they're selling their services. So, for example, Michigan Tech is one of their customers. We buy Red Hat services to make sure that for some of our upper-end software installations, our upper-end programming, are covered, that it works, that the quality is maintained. And we're willing to pay a small fee for that, and those small fees all add up because they're doing it for a lot of people. And so Red Hat can make $1 billion a year, employ hundreds and hundreds of people. So just because we're talking about free and open source does not mean that it's anti-business in any way. You just have to have a different business model than in the past, where you would lock down the intellectual property and then basically sell it to people at kind of one piece at a time. You might have used Firefox as a web browser. I believe it's one of the most popular now. And there's basically an open source variant of every single software package that's been developed commercially. In general, they're very, very competitive. So if you look at, say, a Microsoft Word, and compare that to an OpenOffice or a LibreOffice, it's essentially the same thing. If anything, the OpenOffice and LibreOffices are lighter, more flexible, and faster. And again, if you don't like it or it doesn't have one of the features that you want, well, just code it. Put it in the next version, and you could even fork it, make your own version of your Word product. So when we talk about the hacker ethic, what do we mean? So the good hackers, the white hackers, have sort of a 5-step ethical process. They believe in sharing. So when they write their code, they believe they have an ethical imperative to share it with the rest of the world, because the only reason they were able to do that is because they were standing on the shoulders of giants that came before. They believe in openness so that everybody can get to see it, so that it becomes better. They're always trying to make things better. They're always going for that perfect software program. They believe in decentralization. So they're sort of like a kind of an anti-authoritarian bent to them. They don't like taking orders from people. If you've ever worked with open source software people, they don't like being told what to do. You can ask them nicely and they might help you out, but they don't like being told. They believe in free access, and what they're normally talking about is free access to computers. And this goes back to the olden days when there were very few computers, and you had to like wait in line to be able to code like your little hello world message. Now we all have computers. You probably are wearing a computer now with your smartphone. You probably got one back in your apartment or your like wherever you sleep, and there's computers all over this campus. Computer access in this world and the developed world is taken as a given, but everybody's not on the web yet. And so a lot of the kind of the white hacking ethic is to push computer software and the internet all over the world. And then finally, they believe in kind of world improvement. They believe that the software that they're writing is making everything better. And that has led into this idea of open source appropriate technology. And this is where you're taking the open source idea, that method that works so well in software, and transitioning it to hardware. And the type of hardware that they're talking about is appropriate technologies. And this is a development term that usually is talking about developing economic development in developing nations, but in a way that's appropriate. And so there have been lots of economic development projects. Some of them aren't necessarily good for the people that they're supposedly trying to help. And so the definition of appropriate technology is technology that's designed with a special consideration for the environmental, ethical, cultural, social, political, and economic aspects of the community that you're speaking about. And something can be completely appropriate for one community, and you can go across the street to another community, and it doesn't make as much sense anymore. So photovoltaics in general, because it's environmentally benign, usually economically viable, socially decentralized, is an appropriate technology. And some of it is open source appropriate technology. And I'll give you some examples from that, where you're using the open source developmental method in order to make a better photovoltaic system or a better photovoltaic cell. And the platform that we're going to use in this class, and sort of the largest platform for this sort of finding collaborative solutions to poverty reduction, international development, and sustainability, is Appropedia. And it's sort of smushing Wikipedia together with appropriate technology. That's sort of their goal. It's a MediaWiki interface, so if you've edited Wikipedia, you already know how to use Appropedia. It's advertising free, completely open, completely free to everybody on the planet. So anybody can contribute to it, anybody can learn from it. It's got thousands of authors from all over the world. And my group uses it as our research platform. And in this class, we're going to use it as the research platform for your projects. We do pre-publication work, so our literature reviews, we publish ahead of time. Our methods, we publish ahead of time. And our current research, we tell the world what we're going to do before we do it. And that's very controversial, and I'll explain why in a moment. And then after we finish the publication, so after your papers are accepted at IEEE or wherever we send it to, we're going to post the results of our research in order to make sure that even if people don't have access to the paper itself. So for example, IEEE journals, you have to have a subscription to them. Many people from around the world can't afford the subscription, and if you buy the article one at a time, it's usually about $35. So you can think, particularly if you're thinking about benefiting the majority of the world, they can't afford $35 for a 6-page article. And so you want to make sure that your results are still shared so that they can still take advantage of it. And then the academics that build on your work later would normally have access to the paid version. So the literature reviews, and we'll go into detail in next class on how to do one, but you create a literature review page as the beginning of your project in Appropedia, and you keep a record of all the searches that you do. So for example, if you look for solar energy in Google Scholar, you'd list all the papers that came up, and you'd make a citation list in chronological order so that you can kind of learn as part of this community. So you're newer students into this field, and because of that, you haven't been reading the papers for 30 years because you might not have been alive that long. And so you want to start off with the basics, like what did the people in the 1970s do with your specific problem? Did they even have that problem then? Was it even a physical reality then? And so you start with the kind of the oldest literature and then work your way forward so you can see how it developed, so you become sort of integrated into that academic community. You include the full citation, and you do this so that later on when you go back to write your own paper, it's easy. You don't have to relook it up. You can immediately grab it. You also provide a hyperlink and a DOI. And this is so that if somebody else is using your literature review later, they can get to the same paper that you did. And that might be somebody in this class, it might be a colleague, it might be a collaborator, it might be somebody around the world that you'll never see. And then finally, you want to put your literature review in the appropriate categories. And in the second part of this class, we'll talk about how to do that. But what that's for is to make it so that other people can find your literature review. A few of you have chosen projects where the literature review is already done. And so all you have to do is do basically this last year and make sure that the students that worked on it before didn't miss anything. And for those that have that sort of, drew the lucky card, that is going to be an enormous benefit to you to have this work done already. And what you want to do is to provide the benefit of your service of you doing this hard work of doing a literature review to as many people as possible so we can get the entire field moving forward as fast as it possibly can. The second thing that we kind of open source are protocols and methods. And the primary reason I do this is not the sharing reason. It's the making sure you're doing it right reason. If you put up your method in excruciating detail on the web long before you've done your experiment, and the experts in the field have time to look at it and determine whether it's right or not, that will make it much more probable that when you go to submit your final paper and have it peer-reviewed, that you didn't mess up and maybe use a technique that wasn't accurate enough. That you're using established techniques with open protocols that everybody sort of understands and agrees are the right way to do a proper study. So that's the main reason that we do it, is so we can get input from other academics from around the world to make sure that we're using the sort of state-of-the-art method. Second reason is so that other people can follow your work. So if you're doing an experiment, you say exactly how you did it, and somebody in Italy thinks that would be really awesome, they want to add it to their research, they can take your protocol and immediately follow along and immediately get to where you are so that they can then move forward on the next step. And that next step might be helping you, and that maybe that'll help with, say, your thesis on down the road, or just help the overall sort of progress of the field. So when you do a protocol, it has to be clear enough that an intelligent person can replicate it. And so you don't want to leave secrets. You don't want any secret sauce inside that recipe. You want it all open so that people can get the same materials that you used, use the same equipment that you used, use the same software. Now on the software side, we're only going to use open source software. And so if we're providing the software or borrowing somebody else's software, it's free and open source so that anyone else can use it and anyone else can download it and immediately begin to kind of push the work forward. For the software, you want to make sure that you always maintain the links. And for the experimental apparatuses, you want to make sure that you have summaries of what it is that they are, what their specifications are, so that you can get, for instance, calculated error for the type of experiment you're doing. And again, you want to put it in the appropriate category. Now this is the one that makes my colleagues somewhat uncomfortable. I tell the entire world what I'm going to do for research long before I actually get to it. And the reason that a normal academic would be concerned about this is they would be afraid that they were going to be scooped. Many of the fields, including this one, is highly competitive, and people are constantly fighting to try to get, say, the highest efficiency of a photovoltaic device, or the absolute best dispatch strategy for a hybrid photovoltaic system, so that they can then sell it. And some of those techniques, say, for making a cell, are closely guarded company secrets, and you listen to them give lectures at, say, an IEEE Photovoltaic Specialist Conference, and you ask a question like, well, how thick is that layer? And they're like, sorry, it's proprietary, I can't tell you. So it's closely guarded secrets on how you actually make a functional or record-level device. By putting up on the web what we're going to do long before we've actually gotten to it, what it does is it lights a fire. It forces us to speed ahead. Now, the projects that all of you have taken, I'm pretty sure we're in sort of green pasture area where we're not going to see immediate competition. And so it's fine to be more than establish what we're going to do, and by the time anyone else was able to catch up and try to do what you're doing, you're going to be done already and already have submitted your paper. So you don't really have to worry about being scooped unless it's at the absolute bleeding edge of something that you've been working on for 5 years. But to show you how effective this technique can be, this paper came out in 2010 where I kind of hypothesized what would happen if you applied 3D printing to the developing world for sustainable development. And as part of that sort of hypothesis, what we were looking at was solar powering computers, like this open source computer, solar powering an open source 3D printer, using open source designs, and particularly those that are appropriate for sustainable development, taking an open source recycling unit to grab waste plastic, shove it all in, and power everything with solar. Now, I wrote this paper in 2010, telling everybody in the universe what I was going to be working on. And to this day, I still haven't gotten scooped. We're still the first ones to do all of this stuff. And it's because we're moving very, very quickly. The technological sophistication, for instance, to set up a recycle bot that can make waste plastic into good, high-quality filament is a non-trivial problem. And now there's dozens of companies making waste plastic recycle units, all different kinds, that are all helping lead to this sort of vision of the future where no matter where you are on the planet, you can use essentially waste products and sunlight to generate high-value items for yourself, whether it's for development or just for luxury items. So here's another example. Dr. Weaver actually has one of these ultracapacitor banks that he's working on now, and we published ahead of time what we were going to do with the ultracapacitor bank so that we could do things like have a PV-powered welding system. And we showed these holders for it, our 3D printed open source designs. And so those have already been posted on the web. So if anybody wants to make a capacitor bank like this, they can already use our design, even though we haven't actually published the paper yet on how we're going to do the welding. This is a screenshot from my group's webpage, again, explaining to people long before we've finished what we're going to do and how we're going to do it, and with the clicks to the methods so that they can immediately begin to kind of catch up and work with us. And the last thing that we use Appropedia for is the kind of the results and outreach. So for every completed project, for every paper, we publish a summary of the project and the key findings that we found. Link it back to the literature reviews, because that's sort of the base knowledge that made that paper possible. Link it back to the protocols or methods so that other people can replicate it immediately. Link to the sources of the raw data if we took raw data. So if, say, we had an outdoor photovoltaic testing system and we were recording data every second, we put that up in an open repository so that everybody can use it again if it gives them any benefit. Full citation with the article and DOI. Whenever possible, and that's most of the time, you can publish your paper as an open access repository as well. So for an example, Elsevier is the #1 science publishing house, and all of their journals allow you to put up a preprint on an open access repository. So even if somebody in, say, China wants to read your article and doesn't have access to the Elsevier journal and doesn't want to pay $35 for the nice sort of looking polished published version, they can download your version for free and get access to all the information. And whether or not it's in 2 columns or 1 column, I don't think really matters to anybody. Finally, we publish enhanced figures. So, for instance, a lot of journals will only take black and white or grayscale images. Well, now you can put in a full color version. You can put in one that's interactive. You can put a little video explaining how you designed or built one of the components for your PV paper. And then last but not least, putting internal hyperlinks. So when somebody's reading your summary article and they don't know what a CHP unit is, you can click on the CHP and that'll take them to the CHP page in Appropedia that has kind of basic definitions and then all the other CHP projects sort of following off of it. And in some cases, you can even link to the Wikipedia articles if it's a kind of an uncommon technical term. So when you do this, besides, I think, encouraging students and myself to put your best stuff forward, because this is going up on the web that everybody can see it. It's not being hidden just for a certain faction of the academic world that is only interested in signal processing or only interested in solar electricity. It's for everybody in the world. And that means you're going to get help and criticism from everybody in the world. So you better make sure that your work is good. The help is the kind of the positive side of things. So you get assistance from non-group Appropedia users. There's thousands of people that read Appropedia every day, and many of them know something about photovoltaics or have installed PV systems, or they run a PV company, and they might come across your article or they might come across your literature review, and it could be very valuable for them. And so we've had helpful comments given to us on the talk pages. We've had people from, that had nothing to do with our group send recommendations on how we can move research forward, either in the discussion tab of the article or by emailing either one of the students or myself. We've had people fix our grammar and spelling in our summaries, and this is just it's a nice service. So maybe it was somebody that wasn't overly technically knowledgeable, but maybe it was an English student or an English major that saw that your writing could be improved a little bit, and so did that. One of the most helpful things that people do is add to our literature reviews. And so this often happens where you'll start a literature review, and it's of an interesting topic to the Appropedia community. They will start to help you get the literature review done. Professors will add their own papers to it. They'll add summaries of the work that they did and make suggestions for other places that you should look. And then the hardcore Appropedians will add additional categories, interlink to what you've done, and link to your page from other articles that they're writing in order to give your page more exposure. So here's an example for this. In Appropedia, on every page you can look back at the history. And if you kind of see this guy named Fried Dog, which I assure you was not in our group, and somebody's unknown kind of web address began actively helping us with our literature review. And this made our work better because they were finding articles that we hadn't considered, that we hadn't found by our search terms. And that only adds to sort of your mastery of the subject. You also want to make sure that you provide your data. So many times we have access to data repositories that other people don't. We have a good university, we've got a good strong library, and we have access to some things that others don't. We also generate a lot of data. All of you will be generating at least some data with your projects, whether it's experimental data or simulations. And you should make not only your code for the simulation available, you want to make the raw data that you used. So if somebody else has a similar problem, maybe they want to look at a different geographic area, maybe they want to look at the geographic area that you're studying, but they want to do it in a different way for some other purpose, you want to help them along as much as you can. Now, when you do this, you're rewarded with not just kind of helping the entire world out, you're rewarded with exposure, so that you will get much, much more exposure than a normal academic article. The average citations per article for the average journal article is 1, which means in the history of the universe, one person read your paper and thought it was worth saying, Smith said this. Now that's sad, because you put a lot of effort to get something published. You want a lot of people to read your work. You want a lot of people to use it. And some of the most useful things that we've done for the global community that gets enormous amounts of attention is publishing our methods. And so this particular student, gave a protocol for how to transition from ArcGIS, which is a proprietary GIS package, Geographic Information System package, and what she was doing was trying to find the optimal places to put solar farms in a given region. And she wanted to use completely open source kind of stream, and so we've gone to Graphs that allows you to do that. And this is a couple years old now at this point, her method of doing that has been viewed 10,000 times. So people from all over the world that want an open source method of being able to do GIS are using her method. And it might have nothing at all to do with photovoltaics. It might do with, I don't know, planning out where you're going to put a national park. But now that method is out there for everyone to use. They can use the code snippets that she added to the source and her protocol in order to be able to do that. And so this paper has also been cited many, many more times than one. Overall, the project page has been read more than 2,000 times. And I can assure you, there's not 2,000 solar farm developers in Ontario, which is the section of the world that she worked on. And so that idea, that concept is being spread all over the place in order to help other people kind of build up their solar infrastructure as well. You also get massive exposure because Appropedia, like Wikipedia, is highly interlinked to from all over the web because it's useful information. And so because of that, you've heard of search engine optimization. So if you're trying to have a little small startup company, your main goal is to show up first in the Google rankings. There is a large probability that one of your articles for this class that's posted on Appropedia will show up first in Google rankings. So for example, we published, before we did the study, that we were going to do a hardcore detailed study of the effect of snow on solar photovoltaics. And so if you type into Google, snow and photovoltaics, our study on Appropedia shows up first, and it showed up before we were even done with the article. People were calling us from news agencies before we had even published the work as we were doing it. And the last time I looked, it had been read over 56,000 times. And so this is a concern for people that live in places like this one, where we're covered in snow all the time, and they type it into Google, and they go right to our work that tells them not only how bad it is, and it turns out not to be that bad, but also how to fix it. It also led to funding, and for those of you that are maybe thinking about an academic career after this, one of the primary jobs as a professor is to get funding for your research, and that usually involves writing grants, and you can ask any professor on this campus what they think of writing grants, and it's kind of like the worst part of our job, where you're putting blood, sweat, and tears into something that might turn into nothing. And if you look at the hit rate, like an NSF grant hit rate right now is around 6%. So you have professors from all over the country constantly putting in these massive grant packages that take them like a month to write, and only 6% of them are funded. I funded the largest outdoor test center for solar photovoltaics in Canada with not writing a single grant. And the way that we did it was we had a little mini study. We were doing the snow effects on photovoltaics. We told everybody what we wanted to do. We posted it on the web. At the time, the solar industry in Canada was erupting. It was just growing like crazy. Every single new company that came into Canada wanted to have their stuff tested. And so we built this open solar outdoor test center. And the way that it was set up was we would take your equipment, we would take money to set up a specific experiment that you wanted to do, but you had to agree that the data was shared with everybody else. And so we've got dozens of companies that signed on, other universities that wanted their things tested, they wanted their products tested, they wanted to prove that their equipment was good, they wanted to know for themselves, and they wanted it done in the right way. And this was possible because we had a really well-instrumented outdoor test facility. Now, so that's all the good stuff associated with sharing and being aggressive about it, following an open source protocol when you do research. Now, it's not all good. There is a learning curve. So, and what I'm hoping over the next, basically this week, is to get you over that learning curve. When I ask a normal random college student to edit Wikipedia or Appropedia for the first time, they usually mess up and it's a little bit difficult for them. It's going to take you at least a half an hour to get the basics down, and it'll take you a little bit longer than that to become sort of a super user. And once you're there, then that'll be a skill set that you have for the rest of your life. And I don't think MediaWiki is going away anytime soon. There is a risk that as we're pre-publishing sort of what your class projects are, that someone could scoop us. Again, this has never actually happened to me, so I wouldn't lose too much sleep over it. But if you're very, very concerned about this, we can keep part of what you're doing maybe behind the wraps until at least we validate it and proven that it's the right way. The other concern that you might have is vandalism. If this is an open wiki and I'm grading you on your homework that you're putting up on this wiki, what happens if somebody deletes it and puts up a picture of Snoopy? Like, that would probably not get you a very high grade. But the good news about Appropedia is that, and I'll show you this in the second part of the class, every page, because it has that history, I know who edited it, for how long, how much more data was added to it, and exactly what was changed. It is very easy to reverse vandalism. It's literally one click. And normally, like I've been using Appropedia for classes for several years now, the Appropedian editors, like the kind of the watchdogs of the site, will correct vandalism before you even see it. So you'll only know that something happened if you are searching back in the history page for some reason. You see that the Snoopy picture suddenly showed up, and then it was deleted by an administrator, and then you were just continuing on your way. If you do have any problems, or I don't know, if one of you has a arch enemy that's attacking your pages for some reason, let me know, and I can get it locked down so that only you and certain people can edit it, not random people. Finally, there's a lack of critical mass. So some of you are going to get lucky, and you're going to have a user community within Appropedia that will help you along quite a bit. Some of you are going to have no one ever make a comment on your page or help you in any way. And so right now, Appropedia has thousands of users, but it doesn't have millions of users. So it's not, it's not, if you think about like a movie or something where you post a movie and you look for comments and there'd be thousands and thousands of comments from people watching the movie all over the world. Appropriate technology does not have enough people in it yet to be able to offer that service for everybody. So for some of you, particularly the ones that are doing the PV systems integration, I think there'll be some help. But some of the more off-the-wall stuff that we're looking at in this class, you might be on your own because we're the only ones doing this in the world at the time. So conclusions. We've done a lot of experiments on this open source protocol. I've been very happy with it, which is the reason that I'm continuing with it, and I'm sharing it in this class. And I think for those of you that have advisors and that don't use this method, it'll be interesting to compare sort of how this works with how sort of a more traditional academic research goes. What we found is that you get massive peer review help, generally in the development of your background material, both for your lit review and your experimental design. You get increased visibility in public relations. I guarantee you your Appropedia page will be read more than, say, one of your advisor's top articles, because it's going to be available to everyone, and it's going to be written in a way that's accessible. You have increased funding opportunities. If someone thinks, say, some of you are designing actual electronic components, you might be contacted by somebody like a Spark Fund that commercializes open source electronics and then wants to see it pushed out to more people. And maybe you could start a business on it yourself. Maybe you'll be contacted by funders that just want to see a small company come out of it. I've also found from a kind of a professor standpoint that it's also good for student recruitment. So many of the students that work in my group now are in my group because they were interested in the topic that we were researching. They found us on Appropedia and then contacted the group and said they wanted to join. And so if you're thinking about a career in academia, you'll quickly realize that one of the primary goals of you as a professor is to get the smartest, best, most active, most interested students to come and work with you. And this is a way to recruit them, to pull the best people from all over the world. And then finally, it's good for improved student research-related training and education. It forces you, what you're going to do for this class is you're going to be putting up your classwork on the web for everybody to see. So it's got to be good. You can't do a C-level job in this class. Basically, you are going to get an A or you're not going to be in the class. And you have to do a good job on every one of the projects. It's going to be peer-reviewed as you are doing it. So make sure that you're always acting in a professional manner, that it would be good for you, it would be good for me, it would be good for Michigan Tech. So the way that you start is on appropedia.org. In the upper right-hand corner of every page on Appropedia, there is a login or start a new account button. You click that, and in the next part of this class today, we'll discuss how you use it.